Hi, I'm going to walk you through my lesson planning technique. So the lesson I'm walking you through is the 7th lesson of my unit centered on constant velocity, and this is a unit for my junior-senior physics class. So I like to begin all of my lesson planning with an overarching conceptual focus that I'll eventually itemize as I break down my entire lesson. And the conceptual focus for this lesson is just calculating speed and velocity. So with this in mind, I create my objective, which here is students will be able to determine speed and velocity from written scenarios. I find it useful to start with the general concept in mind and then move from there into the specifics, rather than starting with just a bunch of activities or a bunch of little pieces and trying to piece together the big picture. My assessment for this objective will be students will calculate speed and velocity of various word problems. So with the assessment in mind, I'm better able to scaffold lessons in a meaningful and manageable way, so students know what to expect and know in which way they'll be assessed. So with this overarching assessment and goal in mind, I'm better able to construct activities that will serve as stepping stones to this overall objective and also the overall unit goal. So right now I'll take you through the specifics of my lesson planning techniques. So I'll start at the very beginning, which is a very good place to start. So I begin each class every day with bell work, and this bell work will either activate students' prior knowledge from the material covered in the previous lesson, or it has them start to grapple with concepts that we'll be covering in the current lesson. So in the case of this lesson, I'm going to have them activate prior knowledge by looking at a position time graph. So we're looking at a model of motion that's a little bit different than what we'll be looking at in this lesson, but it's something that we've dealt with and will kind of help bridge the gap between lesson plan 6 and lesson plan 7 and help make this whole unit seem a little bit more continuous. So I'll give them about 3 minutes to work on that bell work. And once class gets started, we'll do prayer at the very beginning. And then we'll just do full group recap of the bell work. So anytime I have them do individual or partner work, I like to do a little bit of full group recap to make sure everybody's on the same page. So I call this full group recap just a board meeting in which they'll gather together and present the problems to the full class. So when I'm diving into kind of new concepts for a lesson, I like to begin the new lesson and the new concept with an easily accessible activity or some sort of discussion that will introduce students to material without completely overwhelming them, especially with quantitative values and problem solving, which physics is full of. So for this lesson, I'm going to start class with just a discussion of relative velocity and relative motion. So in rotating pairs, students are going to discuss various questions related to relative motion. And this will get them thinking about the concepts we're going to be covering in class without being scared off by some of the more complex calculations that we'll be doing by the end of class. And just a quick note, for any time I ask questions or project questions, I like to include them for myself just so I know what we're going to be talking about. So all those questions are listed there, and we'll take about 6 minutes with those partners to discuss and access this kind of new information. So I love to start a lesson with these moving discussions because I find it both gets students more engaged and makes them a little bit more willing to participate when we talk as a full group. And anytime I have discussion in small groups, I like to have full group recap, so we'll do that for 5 minutes after they do their little walk and talk, think, pair, share. So I'll move from this general discussion and this kind of introduction to these concepts to a more specific discussion of the terms we'll be dealing with. And in the case of this lesson, those terms are speed and velocity. So physics is a highly practice-based subject. So I like to keep direct instruction as short as possible because I want to have students grappling with the material as quickly and as soon as possible. So I'll only spend about 3 minutes on this DI, so introducing them to speed and velocity and the calculations to figure out speed and velocity. And after direct instruction, I want students to put the material into practice as soon as possible, so I'm going to have them go straight into partner work to calculate speed and velocity. And these are rather simple calculations just to start them off, just to get them used to the idea. So we're only going to take like 2 minutes to do that. This will also serve as a good informal assessment so I can check student understanding before we move into the more complex problems. And we'll spend a few minutes recapping the solutions as a full group, but not very long because these are pretty simple calculations. So we're going to take just 2 minutes for that. And I'll cold call in this case because all students should have grappled with it with their partner. And once I have evidence from the informal assessment that they've mastered these simple calculations, we'll start diving into more complex problems. Now, before we get into the more complex problems, I want to set them up for success. So I'm going to introduce a schematic and then eventually model this schematic that will help them break up the problems into more manageable chunks. So I'll spend maybe about 5 minutes introducing the guess model. And that will just introduce them to this schematic for problem solving. Then after that, I'll just model a problem for them quickly so they know how to use it. And I'm going to include the sample problem in there just for my own reference. So after modeling this, I'm going to have them attack these problems with a partner. I like to have them use a rally coach activity, which will require them to think out loud when working through problems for the first time. And I find that students gain a better understanding of the process when they're thinking out loud. It also helps them see where mistakes are being made, especially as they're looking on with their partner. So we're going to do Rally Coach just to get them started grappling with these problems. And we'll take about 6 minutes for that. And to review, after they do this Rally Coach activity, we'll go back to whole class discussion, and I'm going to have 2 students model the whole process of thinking out loud so that their classmates can see the whole thinking process and can get used to this whole guess method and solving these more complex word problems. So I'll have 2 students model, so we'll take maybe about 5 minutes for that student modeling in front of the entire class. So to give them a chance to attempt these problems individually and see how much they know, I'm going to give them about 5 minutes to start working on a worksheet that they'll eventually have to do for homework, and this has some of the more complex speed and velocity calculations on it. So I'll have them spend about 5 minutes tackling this by themselves, and then to see if they're on the right track, I'll have them get with their groups, and they'll spend maybe 4 minutes whiteboarding the very first problem on that 3rd worksheet. So this group work will be really useful because it'll help them see, 1, if they're on the right track, or 2, how to get on the right track if they're struggling with the specific aspect of the problem. And then we'll have a little bit of time for presentations of problem 1, so we can discuss any major issues or misconceptions at this point. So a lot of these time frames might seem a little bit arbitrary, but I've actually based them off of how quickly my students tend to get through lessons, how much time they tend to need for specific activities. So these are carefully thought out, and I like to spend a few more minutes, give them a little bit more time to practice with partner work, and only short amounts of time for whole class work, just to make sure everybody is on the same page. So after they have time to present on this last problem, I'm going to assess them individually. So I always set aside 5 minutes at the end of each lesson for an exit ticket. And this allows me to see their individual progress towards this lesson goal and the eventual unit goal as well. So that will be my formal assessment for this lesson. And to give them a little bit more practice, after this lesson, I'm going to have them complete worksheet 3 for homework. So I like to give them tons of time in class to practice, right? We have lots of group work, lots of partner work, and individual work to help them tackle these problems step by step, but I want to give them a little bit more time at home. So if you take a look at all these activities that I planned for this 65-minute lesson, you can see that I like to include a lot of instructional switchbacks throughout the class, which means I don't simply use model, coach, fade in one kind of continuous motion. I have them start off right with individual work on the bell work, then we'll go to group work, then we'll do full class discussion, then we'll do more partner work, then full class discussion, then individual work, then partner work, then full class discussion. Right? I like them to switch constantly through these different types of activity. And this helps keep class moving, but it also gives them a chance to gradually build towards the goal for this lesson plan. Thanks for listening.